Hello everyone, welcome to the next series in the radioactive or nuclear physics section on Dylan Teacher Science. Today we're going to be learning about alpha decay. Alpha decay, so first of all, if you know, there's three types of decay. Alpha, which is the only one you need to know today. Don't even worry about beta or gamma or positron or that. There's a lot of, just worry about alpha decay for now. So alpha decay is when, this is what we call a decay equation. We call this thing down here a decay equation. So we've got uranium-238, which is essentially an isotope which has 92 protons and 238 minus 92 neutrons. I'm not going to calculate. I think it's something 140 something, but yeah. Actually, no, I can actually calculate that. 23 minus 9 is. It'd be 146, I think. So 146 neutrons. Don't count me on that. But anyway, so if it's radioactive, as we discussed in the last video, it has to have more neutrons than protons, but since uranium is above 83 bismuth, it is always radioactive. All isotopes. We have uranium-235, uranium-236, 239, they're always radioactive. So now we've got our 238 uranium. I also wanted to take a quick moment to pause to say, check out my book. I'm writing a book with lessons and questions at the moment, more, sort of that based. Not really going to be, it's going to be completely different material. Same topics, different material, examples, a lot. So if you prefer not watching a stupid kid with a quick voice talking, you're more than welcome to go and watch something like, read the book. Okay, so 238.92 uranium. So if it's radioactive, we all know it undergoes radioactive decay, right? So this one's called alpha. Alpha is the emission of a. So I see when this decays, we draw. This is the atomic number, remember, from last lesson? It's the number of protons and neutrons, and this one here is the atomic number. So that's the atomic mass. This one's the atomic number. Okay, so maybe I should start rubbing out a bit of this stuff. I've got my tissues here, courtesy of the resource centre at the school. Let me get them out. First, I have to open my tissue box. Oh, come on. Sorry about this. There we go, so I have a rubber because I lost one on the way here. Okay, so let me actually get rid of all this. So, when it is radioactive, it undergoes radioactive decay. So we've got our uranium-238. When it's alpha decay, so different types of decay. But during the decay equation, the atomic mass, the top number, always has to equal the atomic mass on this side. And the same goes for the atomic number. So the bottom and top number have to balance in every single nuclear reaction or equation. So we've got this. Now we know alpha is always when a helium nucleus leaves the uranium nucleus. So in this case, the uranium emits an alpha particle. You can write that as either that, or you can write it as alpha. You can either write that as 42He, which is what I do, or you can write it as alpha. It's like a little A. Something like that. I don't know. I don't know how to draw it, but anyway. I'm just going to leave it as 42He for the rest of the nuclear lessons. I'm going to keep it as helium-42, helium-4, which is an alpha particle. So when it undergoes decay, after a certain period of time, this will decay into a new element. So essentially, the uranium's gone, okay, I've had enough. I want to go to a new element after 4.5 billion years, which is the half-life of uranium, but don't worry about that. That'll be a future lesson, hopefully the next few. Once I've done decay types, because next lesson will be beta decay and positron emission. So this we emit a helium particle. So I'm actually going to do a quick little drawing here at the bottom. Now, uranium, it emits. Actually, I'm going to get rid of this and do it again. So I'm going to do more a visual representation of what we're experiencing here. Uranium-238, which that's a very bad circle, so it emits the little alpha particle and then becomes a new element. So I'm just going to call it X right at the moment. So this is essentially what radioactive decay is. We have this going, leaving the nucleus to decay, it's an alpha particle, to produce a new element. Now, what's the new element? Well, it's pretty easy. If you have a periodic table, so remember I said before, all sides have to balance always in every single nuclear equation. No ifs, ands, or buts. They always have to balance. So we have uranium-238. We know that's... Don't ask how you know. I think a quick Google search would tell you, like, for example, uranium-238 would tell you, okay, uranium-238 does alpha. You don't have to know which types of decay each element does. There's no physical way of telling that, unless you can use your memory. Oh, I don't know, but I use my memory or Google it, usually. So if you, say, for example, carbon-14, which has beta decay, you wouldn't be able to tell. Just Google it, really. That's all you have to do. So now we know. So we've got 238 on the atomic mass on this side. We've got 238, and then we've got 92 as the atomic number. Essentially, the bottom number and the top number have to balance. So we need 4 plus what? I'm going to call it x equals 92 on this side. We already know that the way we can do that is essentially do this. We can grab the 92 minus 2 will give us what's on the other side. So 90 plus 2 equals 92. 92 equals 2 plus 90. It's balanced. They're both 92 protons on each side. The atomic number on each side is 92. So 90 plus 2, 92. Same thing. So now we need to do the same for the top number. So I'm going to do this. 238 minus 4. Which equals, pretty obviously, 234. So that's going to be a 234. Then you look at the periodic table. I'm actually going to rewrite this. So this whiteboard's very dirty and running out of space. It's the camera on my phone. So we've got 238 uranium. So we all know it emits an alpha particle when it undergoes radioactive decay. And then we add 1 atom, or I don't know, but we add the new one. Now what's element 90? You'd find it's thorium. That is how you write one. That is all it is. That is that easy. Now, but what do you say, Dylan? What if I were to do this? Give me another equation, Dylan. Alright, I'll give you another one. This one's going to be a more basic one. Oh, actually, do I know any other alpha decays on the top of my head? Thankfully, I have this Wikipedia list that I printed. Thank God I have it at this sort of point in time. Just have to find it. I have a list of most of the occurring radioisotopes in nature. Believe it or not. Let me just find it. Here it is. I have this big old book. It also has atomic masses on the front. I printed this out one day. So it essentially has all the radioisotopes. Most of them, I think these are all the by half-life. Don't worry about half-life yet. So all I have to do is go here, decay type, and I can just find one that's alpha. So I'm going to grab one that will be easy to calculate. Just bear with me. Alright, this one will be an easy one. Bear with me. Okay, so I found one. I think it's radium. No, it's radon. Radon 223. There's our radioisotope. Now what we do, since this one says it's alpha, I'll show you, hang on. Radium 223, 88, 135. Hang on, what? No. That's the number of neutrons. So that's the number of protons and neutrons. You always want that atomic mass, the protons and neutrons, you want that number. And it says alpha. So what we can actually do here is we can go 42He, or alpha, whatever you want to write it. Then we balance the sides, so it's going to be 86 and 219. Oh, yeah, 86. What the hell's element 86? I'm mind blank. Oh, I can't, hang on, I'll find it. I can find it through luckily my atomic mass thing. So we go radon, and we know that one will be astenine. I don't know what the symbol is, but it's astenine. It's astenine. I don't know what the symbol is, but essentially that's all it is. Alright, so comments from me for the rest of the day for you guys. On Dylan Teacher Science, should basically do the following. I want you guys to find on the internet 5 to 10, I'm going to push it a bit this time, 5 to 10 alpha decay equations. Alright, find 5 to 10 of those, And also, stay tuned for book. Stay tuned for the book that I'm writing. Thank you guys for watching this. I'm running over my 10-minute time limit, so I might want to stop now. But anyway, so we all know, I'm just clarifying one thing quickly before we stop. Alpha Decay is emission is the emission of a helium 4 nucleus. Thank you guys for watching.